Now let us see. In a school, okay, 25% of students failed in language, first language, and 15% of the students failed in second language, and 10% of students failed in both. Fine. Now, if a student is selected at random, find the probability that he failed in first language if he had failed in second language, and the second one, he failed in second language if he had failed in the first language. Okay. And continued with the problem. He failed in either of the two language. So these are the now that let us consider L1 as the first language set. Okay. L2 as the second language set. Okay. So now let us collect the data in the given problem. What all is given? Let us select that. So probability of L1 will be now 25% will be 25 by 100. So you get 1 by 4. And L2, it is 15%.
15 by 100.
15 by 100. So you get 3 by 20. And the probability of L1, both, right? Yeah. How much? 10% of students failed in both. So L1 intersection L2, both. So that will be 10%. That is 1 by 10. You got this. So this is given for us. Let us prove the, let us try to solve the first one. Okay. Now, the probability of L1. Now, he failed in first language. If he had failed in second one, then L1 given L2. That's how it is. Yeah. So we know the formula. This is the conditional formula. P of L1 intersection L2 divided by P of L2. So can you tell me what do you get?
No.
Yeah.
3 by 20.
2 by 3. 2 by 3. After simplifying, you get, okay?
Yes.
Yeah. Now, second one was if like he failed in second language. Okay, can you help me with that? Second language. So
Yes.
it is L2.
Mm.
If he had failed in first language, so it will be given L1. Fine.
Yes.
This will be L2 intersection L1 and P of L1. Now again, these L1 intersection L2 is same as that of L2 intersection L1.
Mm.
So this is
1 by
1 by 10 by this is 1 by 4.
1 by 4.
So you got this as 2 by 5. Fine.
Yes.
Yeah. Now the last one, he failed in either of the two languages. Either two languages. Let us see this. So either in the sense P of L1 union L2.
Yes.
Yeah. So this will be since we have the formula L1 L2. Okay, minus P of L1 intersection.
Minus 1 by 10.
Yeah. This is divided. After this. Now three machines A, B, and C produce respectively 60%, 30%, 10%. A, B, C produce 60%, 30%, 10% of the total number of items of a factory. The percentage of defective output of these machines are respectively defective with respect to A, B, and C are given, that is 2%, 3%, and 4%. These are the defective with respect to the machines A, B, and C. Now, an item is selected at random and is found defective. Okay. So, we select an item, okay, from A, B, and C, and found that it is found defective. Now, in that, you have to find the probability that the item was produced by machine C. Machine C. Okay?
Yes.
Yeah. So let us see how to solve this. Let us write down that the probability is P of A, which is 60%, 60 by 100, that is 0.6. Probability of B, which is 30 by 100, which is 0.3. Probability of C, which is 10 by 100, which is 0.1. Now, let us label this defective as D. Okay. Now, here's so sure that the defective from A, okay, given A, is 2%, is 0.2. Can you help me with this? D? What is it?
By 100.
0 by
equal to
0.3.
0.03.
0.3.
0.03.
Yeah. And last one?
0.04.
0.3. So now we have to find the probability of C given D, because here the defective we know that is from the machine C. We are so sure because it is given. Let's find this. Now probability of, what is the formula? Probability of AI given A is probability of AI, probability of A given AI is summation I is equal to 1 to n P of AI, probability of A given A. Okay. Now,
Okay.
looking into this, we have these values. See, P of A, P of B, P of C, and P of D given A, D given B, and D given defective in A, B, and C. Okay. By looking into this, let us try to implement here. So in the numerator, it should be P of C, P of D given C, and this should be the summation. See here in the denominator, so the summation of A, B, and C, 1 to n. Here, 1 to 3, which is nothing but A to C. So this will be P of A, P of D given A, okay, P of B, P of D given B, P of C, P of D given C. Fine. So we have got only 3 machines. So if n number of machines are there, we can close. Okay. So,
Yes, sir.
yeah. So after solving it, okay, by substituting all the, okay, so you get as 0.16 by substituting all this. Now, in a bolt factory, there are 4 machines. In a bolt factory, there are 4 machines A, B, C, and D. In manufacturing, respectively, 20%, 15%, 25%, 40%. Right? Out of this, we have defective again here, which is of 5%, 4%, 3%, and 2%. These are defective. Now, if a bolt drawn at random was found defective, a bolt drawn at random is found defective, what is the probability that it was manufactured by A or D? A or D? Let us see how to solve it. Okay.
Yes.
Yeah. So let us quickly write down what is probability of A, which is 0.2, probability of B, which is 0.15,
0.15,
0.25, and D, which is
0.4.
0.4. Fine? Yeah.
Yes.
Now, if you call this defective as X, okay, if you label this defective as X, so probability of the defective, which is X given A, which is 0.05, probability of given X given B, which is 0.04, probability of X given C, which is 0.03, and probability of X given D, which is 0.0. You have been given this. Fine?
Yes.
Yeah. Now, there is a change in question. Okay? Like, it was asked A or D. A or D. Okay? It, like, if a bolt was drawn at random, was found defective, and what is the probability that it was manufactured A or D? Okay, so defective in that. So all is union. So probability of A union D, right? Either A or D defective. So this is how you have to find. Okay, since A and D are mutually exclusive, so mutually exclusive means fine. Now let us find what is uh, P of A given X, and then afterwards find P of D given X. Okay? So P of A given X is P of A by using Bayes theorem, X given A, and P of A, P of X given A, like that. We have multiplied, sorry, summation, right? Plus. So this will be P of D, P of X given D. Okay? So this is how we find what is P of A given X. So after simplifying, you get 0.3175 by substituting these values. Uh, X given A, X given C, B, and A. Okay, fine.
Yes.
Yeah. Now we have to find P of D given X. So let us put that P of D given X. Okay. P of D. So since we have this P of X, again this is the same thing. P of A, P of X given D, and so on. P of D and P of X given D. Okay.
Yes.
After simplifying this, you get 0.254. Okay. So you got P of D given X, and also we got this P A given X. Okay. Now you have to find the P of A union D given X is P of A given X plus P of D given. So this is 0.3175 plus 0.254. So 0.575.